Hello students, subscribers, viewers, and future engineers. Here is problem 14.5 with the aid of software to verify our solutions and answers in the preceding matrix structural analysis problems, originally from problem 9.5 solved by three-moment equations, 10.5a by slope deflection equations, then 11.5a by the moment distribution method, 11.5b by the purely matrix approach, and this time 14.5a by the combinations of matrix and the verification using this software RISA 2D. So I will no longer explain the details because I already presented the solutions to the previous method. So just to review, due to the side sway or support settlements, the effect of the loads are incorporated in the results of RISA. So we just consider the effect of these support settlements. Fixed moment BC due to settlements or side sway is equal to fixed moment CB, and negative 6 EI. So in this portion here, EI is 120,000 kilonewton meter square, because I is 500 times 10 to the 6 and modulus of the elasticity 200 gigapascals. So the product is 100,000 kilonewton meter square. So if I is 1.2 of 500 times 10 to the 6, so EI would be 120,000 kilonewton meter square. Rotation of chord BC is counterclockwise. 12 minus 8 is 4 mm, that's delta. So delta, which is 4 mm, is treated negative. So negative 6, 120,000, negative 0.004 meter, which is delta over 5 square. So we have 115.2 kilonewton meter positive. And if it is positive, it is clockwise, as shown here, 115.2. Then for 115.2 for CD, negative 6 EI is 100,000 because the moment of inertia is I, just I. Then delta, the chord rotates clockwise for CD, and delta is 14 minus 8, 6 mm. So 6 mm is treated positive in the slope deflection equation side sway moment formula. So negative 6, 100,000 times 0.006 over L square 6 square, so negative 100 kilonewton meter, and it is counterclockwise as shown. Then fixed moment DE, which is also fixed moment ED, is equal to negative 6 EI is 150,000. Delta is treated negative because the rotation of chord DE is counterclockwise, and delta is 14 minus 6, so 8 mm, so negative 0.008 meter over L square 4 square will get positive 450, so it is clockwise as shown. Then we have to consider the construction of the beam and the assignment of these beam properties in RISA. So we have loading at A negative 15 or 15 kilonewtons downward. By the way, the fixed forces are solved in the following manner. So since we have 115.2, so the fixed force here should be downward. And this is obtained as fixed force FBC times summation moment C times 5 times 5, that's counterclockwise, plus 120 equals 115.2 times 2. So 115.2 times 2 minus 120 divided by 5 will give us sorry, just the just due to the fixed moments. So this 46.808, because the loading is there already, so we'll just compute the fixed forces due to this sideway moment. So fixed force VC times 5 equals 115.2 plus 115.2. So that we'll get 46.08 kilonewtons. So since there's no other load, vertical or downward load on BC, so we expect that the fixed force CB is numerically equal to 46.08, so it is upward here. Then for portion CD, this 33.33 kilonewtons is upward by summing up moments about D. So fixed force CD times 6 equals 100 plus 100. So you'll get 33.33 kilonewtons upward. Then since this fixed force is due to these couples, therefore the reaction here should be opposite to that. So 33.333 kilonewtons downward. And for portion CD, the reaction is again, fixed force is again expected downward. So fixed force times 4 equals 450 plus 450 or 900. So 900 over 4, 2 to 5 downward here. So on ED, 2 to 5 upward. Then for the net loading, so remember these are fixed forces, so the loading would be opposite. So that's why we have, because this is fixed force, so we have to apply upward opposite to this 46.08 upward at this support B here, 46.08 kilonewtons. Since this is clockwise, so the loading in the software should be counterclockwise, 115.2 kilonewton meter. That's positive because in the software counterclockwise rotation is positive. Then at C, we have 115.2 clockwise minus 100 counterclockwise. So the net fixed end moment at C is 15.2 clockwise. So the loading should be opposite to that, 15.2 counterclockwise. So we have 15.2 kilonewton meter counterclockwise here. And since these are upward forces, 46.08, 33.333, so the load should be downward. The sum of these two is negative 79.413 kilonewtons. Again, that's 46.08, negative 46.08, negative 33.333 is negative 79.413 kilonewtons. At D, for the net couple load, this is counter, this is clockwise. So 450 clockwise minus 100 is 350 clockwise. So the loading should be 350 counterclockwise, opposite to clockwise net fixed moment. So 350 counterclockwise kilonewton meter, and the loading downward, which is treated positive, 333.333 plus 225, that would be 258.333, opposite to this fixed end forces, so upward. Then finally at E, we have a couple of clockwise 450, so it is counterclockwise 450 here. Then 2 to 5 upward, so downward negative 2 to 5. And of course, this would be the original loadings. So after you pull down menu solve, we'll get these reactions and axial forces. So the reaction at B is 24.12 kilonewtons, exactly, which is equal to the reaction at B by the previous methods. Reaction at C, 46.813 kilonewtons. Reaction at D, 39.269 kilonewtons. Reaction at E, 96.799 kilonewtons. But for the moments, we have to adjust it. So moment at C is negative 4.407, the result of RISA here. Then we have to add the moment, fixed end moment, which is in this case negative 100, because this is counterclockwise. So negative 4.407 plus negative 100 is negative 104.407 kilonewton meter, as compared to the result by the previous methods, classical methods, negative 104.406 kilonewton meter. So there's a difference of 0.001, and that is acceptable because here in RISA, in this software, these loads are limited to 3 significant figures, and the results in the preceding methods were accurate, but this is also accurate. That's acceptable, except for moment at D. So we have negative 362.796. Then this is clockwise, so plus 450, you will get 87.204 kilonewton meter, as compared to 87.187 in the classical methods. So, but that's very close. 87.204 in the software, but in the classical methods 87.187 or 19. So that's practically the same. So that's it for this video.